Well, we've spent a lot of time this week talking about the impossible math problem that we're dealing with. As we talk about all the new computing that we're trying to get done is demanding so much more out of our infrastructure and out of the ways in which we house our equipment that we need new answers. And some of it's going to come from just being smarter about how we're deploying that equipment, the architecture that we're using. We've seen a lot of really neat stuff on direct chip cooling from Silicon One, and some of the options there. But there are more answers, because we'd seen a little bit here, but I did not realize that we were working on this from a almost an incubation perspective. But I'm going to introduce Thierry here. Thierry, thank you so much. You mind explaining, because we're going to talk about immersion cooling.
Yes.
And you actually blew my mind with the efficiency on some of this stuff, but this is what your team is doing, as I understand it, is you're working with partners to figure out how do we solve this problem in unique ways that can eventually become, I won't say productized, but certainly more palatable or doable as we look to the future of where that's going to come from. I don't know if that's fair.
Yeah, yes, correct. So we are on the Purpose Pavilion, and it's about AI-ready data center and how to better cool the system, okay? And we are relying on a liquid cooling technology, but in particular immersion technology that exists over years for HPC systems. So it's a proven technology.
Yeah.
And now with this, we have worked on a program allowing to test our system and check the advantage of that technology. It relies on a fluid that absorbs the heat 25 times more than the air. So it brings advantages. So at first there is no dust, it's not flammable, not conductive, and it prevents from temperature peaks. And so there is less stress on the component. And also you have higher density because you don't need the space between the servers to have the air circulating.
Yeah, because you get this this dielectric fluid that you mentioned is non-conductive, safe. It's not something we need to worry about as humans.
Yeah.
Correct. And then so it can absorb more heat and obviously can get into the nooks and crannies because this not only changes the facilities in which we put our gear, but it also changes sometimes the way we design our gear. Because we've had examples here where the air cooling meant you were looking at a 3RU box versus 2RU when it did some on-chip cooling or some kind of hybrid. So now all of a sudden you can work with stuff because of the efficiency of getting that heat away from the components, which as you said also extends their life expectancy.
Yes, exactly. The maintenance can be reduced by 50%.
50%.
The energy used for the cooling in the whole system by 40%. The total cost of ownership, consequently, is reduced by 50% as well over 10 years.
Yeah.
And another element very important is the floor footprint because of the higher density. So then you can have much more in a less footprint. I can
you have a picture that I loved, and I asked you to prep this for
animation.
me. So this is your typical, and then as you begin to try and replace this, because I approached you thinking, oh, we need specialized facilities to build because you do talk about there's this tank that has gear in it facing up, so it's a little bit of a different way of thinking of it, but then the idea is that fluid, the heated fluid needs to be taken over to a condenser or to some way to translate that and then flow back in. People are looking at how do we reuse that heated fluid to potentially offset costs of heating a building or something like that, right?
Yeah, exactly. So there is an heat.
That's amazing.
There is an heat exchanger. So you have the fluid,
that one has it in there. Okay.
the fluid that circulates, against water that circulates. So then this water can be sent to your system to heat your building, or it can go into your regular chiller also and come back at 18 degrees Celsius, and then it's good. And you can see that it's in a regular office workplace with a desk because there is no noise, there is no fan, and no vibration. So for people bringing back in their premises AI, data, models, security, you don't need to build a data center, a new data center, if you don't have one. You can just set this as it is in regular offices. So it's really important, in particular in Europe, this sovereignty umbrella.
Yeah, how does that, what is the sovereignty messaging there? It's, in other words, because you're going to bring it in-house, but you may not have time or budget or just whatever the constraints may be to be able to have the right facilities to be able to bring that on premise?
Yes, so the idea is really simple. It's just a partial decloudification of your system.
Unclouding.
You just uncloud it. So you just bring back stuff that were in the cloud, mainly your critical data, your critical AI models, as well as the local security, and you can operate them directly. Yeah. It's a new Neo private cloud, still connected with the rest, but you are fully in control of the system.
Can you tell me, I wanted to look at this over here, and I was excited to play with this remote control, but so this is a demonstration, this is a UCS server that you got fully immersed, which just blows my mind, because it's got power, and then of course I just like playing with the fact that it goes up and down, which is much more fun than my sit-stand desk at my house. But what's important to understand about this? Obviously the vertical orientation, you've got the cables coming up through here. What else do we need to understand about this?
So just to show that it's really easy to operate with this system, of course in a big tank like this, you have a crane, as you said, that allows you to take this. So you can remove rams, etc. In 3 minutes, it's dry, so you can really operate, etc. Then you bring it back, and that's it.
Because for most people, I mean, how often, in most situations, of course, I remember old Cisco routers that have never been turned off, you know, at some points. And obviously, these are more complex. But in general, once you get these things configured, you're not having to touch them much anyway. You want this to be untouched in most situations.
And in particular, with this system, you have much less failures. So you will have to operate much less oftenly.
That's interesting too. Yeah, but, is that a condition of the fact the heat that normally causes component degradation?
The dust, etc.
Oh, and the dust. That's a great point. We're not, the fans aren't pulling in all that junk from around us.
And the fluid, that is a biofluid, is warranted 10 to 25 years. So you don't have to change it or recycle it, etc. every year. And it's
no smell.
Yes, and it's biodegradable, excuse me, in 1 month. So it's really clean.
So as we wind this up, what is important to understand about what your group is doing and how our audience, which includes practitioners, customers, partners, in general, what should we know that could help you achieve what you want to moving forward for your group?
So it's available, it's arriving, and we are working with an ecosystem of partners to make this available for our partners and our customers. And we are working within Cisco to focus in particular on one use case, the Unify Edge.
Oh, okay.
That is particularly appropriate for edge DCs, and this is typically an edge DC use case.
So we're going to see some GPUs floating in here.
Yes, if you go on the AMD stand, you will see the very same with GPUs.
Okay, that's perfect. Thierry, thank you so much.
Thank you very much.